All right, we're going to continue working on Common Assessment 2, Practice Test 2, and we're going to get into inequalities, and we're going to get into compound inequalities and how to work with them and what they all mean. And so we're going to talk about number 5 first, and we'll see how we can work with compound inequalities and how we can check our answers. So number 5, we have a compound inequality that's separated by the word or. And I'll talk more about that in a second, but when we have a compound inequality and it's separating our two statements, we can solve each statement individually. So the first thing I'm going to do is solve the statement on the left-hand side. 3x is greater than or equal to 3. So of course, I divide both sides by 3, and I have x is greater than or equal to 1. And now I'm going to solve the statement on the right-hand side, and I'm going to divide by 9. When I divide both sides by 9, I have x is less than negative 6. But what I can't afford to do is ignore the word or. So I must include the word or because that's going to impact how I graph. So now we have, just like any inequality, we finish our solution and we have to graph our solution set. So we have x is greater than or equal to 1. 1 would be kind of over here. Or x is less than negative 6. And negative 6 would be kind of over there. And so we graph each solution set. And I'll start with the negative 6 because it's further on the left. So I'm asking, am I having an open or closed circle? Since it's only less than, not or equal to, it's an open circle. And so I have an open circle and it's less than, so I'm going to go in the direction that has less. And now I look at 1. Open circle or closed circle. It's or equal to, so I have a closed circle. And then I'm saying x is greater than or equal to 1, so all the numbers greater than are to the right. And I have my graph. Now this doesn't mean I'm done, because what I have to do is check my answers. And the way I check my answers is I use this word or. So I look on this side of the graph. Are these numbers bigger than 1 or less than negative 6? And because I'm saying the word or, and they are less than negative 6, then yes, this is part of our solution set. So this graph, this part of the graph, stays. And now I look, and I'll give it a check mark. And now I look at the numbers in the middle. Are these numbers bigger than 1 or less than negative 6? And absolutely not. No, they are not. They don't even fit either of the bill. And now we look all the way to the right-hand side. Are these numbers bigger than 1 or less than negative 6? And yes, they are, because we said or, and because these numbers are bigger than 1, this part of the graph checks out. So it turns out that this graph that we have graphed is indeed our solution set. So now I know this is the solution set because I checked it through. And that's how we can work with compound inequalities. So now that brings us to number 6. So when we look at number 6, we have negative 8 is less than 4x minus 4, which is less than 12. So we have another compound inequality, but this time it's kind of smushed together. And if it's smushed together, it's automatically an and compound inequality, automatically. And the way we approach this is the same way we approach any equation. We identify our variable, and we undo all the things that are happening to it. So we have 4x minus 4, and we're going to undo everything around that x. So the first thing we have to undo is the minus 4, and so we're going to add 4. And add 4 where? We're going to add 4 everywhere, on the left-hand side, in the middle, and on the right-hand side. So when we have our compound inequalities, that's how that works. So negative 8 plus 4 is negative 4. I'm left with 4x in the middle. And on the right-hand side, I have 16. I'm going to continue to undo what's happening in the middle. What's happening to the x being multiplied by 4. So we're going to undo that by dividing by 4. And if I divide by 4 in the middle, I have to divide by 4 on the left-hand side, positive 4, and divide by 4 on the right-hand side. So on the left-hand side, negative 4 divided by 4 is negative 1. My inequality symbol changes or stays the same. X is in the middle, and then 4 on the right-hand side. And so I have my inequality, negative 1 less than x, which is less than 4. So how do we graph this? Well, take a look at what the statement is saying. It's saying x is bigger than everything that's -1, and x is less than 4. So basically, it's everything bigger than -1 and everything less than 4. So it's basically everything in between. So we have open circles, and it's everything in between. And that's what that statement means. So we don't even have to check because we know that's what that statement means. It's everything in between. And there's our graph for number 6. And now we look at number 7 to see, well, what's going to happen with something a little bit more complicated. So with number 7 on the practice test, we have 6x minus 10 being greater than 3 plus 2 times 3x plus 4. And so we're going to talk about what are the concepts here because we're dealing with an inequality. So remember, we're going to simplify first. On the left-hand side, there's nothing to simplify, so it stays the same. On the right-hand side, remember, if you call that 5, that's a big, big mistake. That's a boo-boo. We have to multiply the 2 before we add it to the 3. Okay, so make sure you avoid that mistake. The 3 stays put, and now we're going to have plus 2 times 3x is plus 6x, and then plus 2 times 4, which is plus 8. Okay, and so we're going to continue simplifying now. On the left-hand side, 6x minus 10. On the right-hand side, 3 plus 8 is 11, and then our plus 6x. So now everything is simplified. We have simplified first. But what we're going to do is undo variables. Remember, we undo variables first. So we're going to either undo the 6x here, or we're going to undo the plus 6x over here. Either way, we're going to take away 6x. So if we take away 6x from one side, we have to take away 6x from both sides. That way, we keep it balanced. On this side, we'll be left with -10. On this side, we'll be left with 11. And just like before, we've seen this. Oh no, the variable cancels. And if the variable cancels, we have to read this out loud. And when we read our statement out loud, this is what we're going to say. -10 is greater than 11. What? That makes absolutely no sense. -10 is greater than 11? No, it does not. It is not. -10 is way less than 11. So this is an untrue statement. And if we're left with an untrue statement, that means our solution set has no solutions. So we have to be very careful with what we're doing with our math, and then we have to understand how to find our solution set. And that's how we work with inequalities.